In the last two lectures, we calculated the cyclicities of decimal digits. And now we are going to use the obtained cyclicities to find out the digit at unit place when we have large powers in the calculation. So this means we are going to perform the unit place calculation with the help of cyclicities of decimal digits. Now in the part 1 of unit place calculation, we will focus on 4 digits, and these 4 digits are 0, 1, 5 and 6. We are keeping 0, 1, 5 and 6 together in the same group because when you focus, you will find their cyclicities are similar. 0 has cyclicity equal to 0, 1 has cyclicity equal to 1, 5 has cyclicity equal to 5 and 6 has cyclicity equal to 6. This means for these 4 digits, the cyclicity is equal to the digit itself. When you calculate the powers of 0 or 1 or 5 or 6, you will always get the digit itself at the unit place. And now we will move on to the case when we have 0 as the unit digit of a number n. If 0 is the unit digit of number n, then the unit digit of n raised to power small n will also be 0. This means if we have a number n and this number n has 0 at the unit place, or we can say that 0 is the unit digit of number n, then if we calculate n raised to the power small n, then the result will also have 0 at the unit place. So I hope this point is clear to you. And now we will see one example to understand this point better. In this example, let's say number n is equal to 260. And now let's say we want to calculate the unit digit of 260 raised to power 7. And as per this rule, the unit digit of 260 raised to power 7 will equal to 0. So n raised to power small n will have the unit digit equal to 0 because n, which is 260, has the unit digit equal to 0. Now let us move on to our next digit, which is 1. If 1 is the unit digit of number n, then the unit digit of n raised to power small n will also be 1. So the same rule will be there for digit 1. Let us take one example. Let's say we have 91 raised to power 9 and we need to find the digit at unit place. So first we will focus on the number n, which is 91 in this case. So the unit digit of number n is equal to 1. And therefore, as per this rule, 91 raised to power 9 will also have the unit digit equal to 1. And similarly, we have the same rule applicable when 5 and 6 are the unit digit of the number. So this means if 5 is the unit digit of n, then the unit digit of n raised to power n will also be 5. For example, if we have 35 raised to power 6, the unit digit of 35 raised to power 6 will be 5 because 5 is the unit digit of number n. So n raised to power small n will also have 5 as the unit digit. Following the same rule, if we have a number in which 6 is at the unit place, then the number raised to power n will have 6 as the unit digit. So I hope you now understand how to find out the digit at unit place when we have 0, 1, 5 and 6 at the unit place of a number raised to power n. Now we will move on to our example problem. In this problem, we are required to find the digit at unit place of 211 raised to power 177 plus 126 raised to power 31 multiplied to 175 raised to power 196. There are 4 options. Option A is 31, option B is 1, option C is 0, and the last option, option D, is none. We are required to find out the digit at unit place when these two powers are multiplied and then the result is added to this power. We do not want to literally perform this calculation and then find out the digit at unit place. Instead, we want to use the rules we just discussed. We will focus on these powers independently and we will try to find out the digit at unit place of all the 3 powers we have. And once we have the digits at unit place for all 3 of them, we will perform the multiplication operation and then we will perform the addition operation. So let us shift our focus on this 211, which is our number n, is having 1 at unit place, and therefore following this rule we will have 1 at the unit place of 211 raised to power 177. So from here we will have 1 at the unit place. Moving on to 126 raised to power 31, we have 6 at the unit place of number n, and therefore from this rule 126 raised to power 31 will also have 6 at the unit place. Similarly, for this power, following this rule, we will have 5 at the unit place of 175 raised to power 196. And now we will multiply 6 and 5 because here we have multiplication. After this, the result will be added to 1 because here we have addition. 6 multiplied to 5 is equal to 30. 30 plus 1 will give us 31. And we can clearly see that the unit digit is equal to 1. So 1 is our answer of this problem, and therefore option B is correct. So this is all for this lecture. In the next lecture, we are going to discuss the cases when we have digit 4 and digit 9 at the unit place. So I will end this lecture here. See you in the next one.